Hello, this coming video is about the application of derivative. So it will be a long video and we are going to discuss about the tangent line, normal line and maximum or minimum of a function. So let us go through this application of the derivative. Later on we'll continue in other applications.
Okay, now the first application is the equation of the tangent line to the curve. As you know that derivative of a function is the gradient of the tangent line. So that I can write some examples of that. Therefore, if y is equal to, if y is equal to f of x, the equation of tangent line at x equal to a is, m will be equal to f dash of a. That means you find the derivative of f of x and put a. That is your m. Now, the point will be, the point is x equal to a, so y will be equal to f of a. So now we can write the equation of the line, which is y minus y1 equal to m times x minus x1, or whatever method you know. Perhaps you know some other method. If y equal to mx plus c, you can use that method also. Anyhow, the equation will be y minus f of a, which is equal to f dash of a times x minus a. For this is the equation of tangent line. Now, the next application is the equation of the normal to the curve. The normal to the curve is actually a line which is perpendicular to the tangent line at the point of intersection. That means if you have a curve like this, now you may have a tangent line which is like this. Not accurate actually. I will try once more. If not possible, then I will. Okay, this is the tangent line. Now you have another line which we call it normal, which is actually perpendicular to this at this point. Therefore, this is the normal line. Therefore, this is the normal line. Therefore, this angle is 90 degrees. So this is called normal line, and this blue color is the tangent line. So, since the angle between them is 90 degrees, therefore we know that m, this is the equation of normal line. We know that m times m dash is equal to -1. That means if two lines are perpendicular to each other, the multiplication of the gradient is always -1. Therefore, now m dash is equal to -1 over f dash of a. So the line will be y minus f of a equal to -1 over f dash of a, which is gradient of normal x minus a. Now I will give an example. It will be much easier after that. Now, let y equal to f of x equal to x squared minus 5x plus 2. Find the equation of tangent line tangent and normal lines to the curve at x equal to 2. First of all, if x is 2, how much is y? Because I need a point. X is 2, how much is y? You can substitute here with 2 squared minus 5 times 2 plus 2. And easily calculate this. This will be equal to 4 plus 2, 6. 6 minus 10 is negative 4. Therefore, the point is 2 and negative 4. Now, let us see what is dy by dx. dy by dx is equal to 2x minus 5. So, at x equal to 2, the value of that is 4 minus 5 is negative 1. So, m is equal to negative 1. I can write it y equal to mx plus c. You can do this method also. Therefore, y will be equal to negative x plus c. We know that from here, when x is from here, we know that if x is 2, y is negative 4. Therefore, negative 4 is equal to minus negative 2. Sorry, not negative 2. 2 plus c. So this is negative 2. The c will be also negative 2. So from here I can say y equal to negative x negative 2 is the equation of tangent. Now, m prime will be equal to negative 1 over m. Negative of the reciprocal. Therefore, negative 1 over negative 1. Therefore, it is 1. So, y will be equal to x plus c. Again, the same point. Same point here we are having. Therefore, now x is how much? X is 2, y is negative 4. Negative 4 is equal to 2 plus c. So, from here I can say c is equal to negative 6. Therefore, the equation of the normal will be y equal to x minus 6. Therefore, this is normal and this one is tangent. Is the equation of normal to the curve. Okay. This is the equation of normal to the curve. Now, for example, I can give another example. Suppose y is equal to x, ln of x. We want to find the equation of the normal to the curve at x equal to 1, suppose. Find equation of tangent at x equal to 1. First of all, x is equal to 1. Let's see how much is y. Y will be equal to 1 ln 1. We know that ln 1 is 0, therefore this will be 0. Therefore 1, 0 is the point. Now we want to find the equation of tangent. First I have to find dy by dx. You can see that it's a product of two functions, x ln x. Therefore I have to use product rule. Therefore derivative of the first one, which is x, is 1. Therefore 1 times ln x plus derivative of the second one, which is ln of x. ln of x, derivative will be 1 over x times the first one, which is x. Therefore, after simplification, I'm going to get ln x plus 1. X is equal to 1. At x equal to 1, I'm going to get ln 1 plus 1. Therefore, this ln plus 1. ln of 1 is 0, therefore the answer is 1. Therefore, m is equal to 1. Now I can write the point. Now we know that y is equal to mx plus c. Now, m is how much? M we calculate is 1. Therefore, y is equal to x plus c. We know that at x equal to 1, y is 0. Therefore, we can substitute. 0 is equal to 1 plus c. Therefore, c is equal to negative 1. So, we are going to get y equal to x minus 1 is the equation of the tangent. So, we can find the equation of the tangent to different curves. For example, if we have, now I'm going to find one equation of normal. Suppose y is equal to 2x plus 1 divided by x minus 1. Find the, this is another example actually. Let me write the example here. 2x plus 1 divided by x minus 1. Find the equation of normal to the curve. Okay, x is equal to 2. Let us see how much is y. Then y will be equal to 2 times 2 plus 1 divided by 2 minus 1, which is 5. Therefore, we have the point 2, 5. Now I need to differentiate this function, dy by dx. Now we know that this is quotient rule. Differentiate the numerator, then multiply by denominator. Therefore, differentiate here, and then multiply by this. And then go other way around. Now, that will be 2. Derivative of the numerator is 2 times x minus 1. Minus differentiate the denominator, which is 1 times 2x plus 1. Divided by x minus 1 square. You can see that this is, if you simplify this, this will be actually 2x cancels the 2x, minus 2 minus 1 is minus 3, negative 3 you have here, x minus 1 square. Now we want to find it at x equal to 2. At x equal to 2, this will be actually 2 minus 1 is 1, 1 square is 1, therefore is negative 3. This is the gradient of the tangent line. Negative 3 is the gradient of the tangent line. What we want? Normal. Therefore, m dash will be equal to minus 1 over m, which is minus 1 over negative 3, which is 1 over 3. Therefore, your m is 1 over 3. Therefore, your function will be y equal to 1 over 3x plus c. You know that x is equal to 2, so x is equal to 2, y is equal to 5. Therefore, 5 is equal to 2 over 3 plus c. Therefore, c will be equal to 5 minus 2 over 3, which is 15 minus 2 will be 13 over 3. Alright, therefore the equation will be y equal to x over 3 plus 13 over 3. So this is the equation of the normal to the curve. Now, the next important application of the derivative is the function is increasing or decreasing. Now, look at this. Suppose I have a function like this, suppose. I have a function like this. Look at this function. Now, here, from here going up till this point here at the top here, y dash, that means dy by dx is positive because the function is increasing. As x increases, y also increases. Therefore, the change of y divided by change of x, both of them are positive, so that this will be positive. At this point, the gradient is 0. Y dash is equal to 0 because at this point there is no slope. The slope is 0. When you are coming down from here, you are coming down till this point here. Therefore, from here, while you are coming down to this point, then as x increases, y decreases. Therefore, change of y to change of x will be negative. Therefore, y dash is negative. But at this point, again, y dash is equal to 0. So, here also, y dash will be positive. We can see that the function is increasing. Therefore, y dash is more than 0. So, the sign of the derivative will help us to understand the function is increasing or decreasing. And with using that, we can find the local minimum and local maximum. Local minimum and local maximum means this is a local maximum. It is not completely maximum because this is more than this, but in the neighborhood of this point, this is maximum. So, let us give one example. Suppose I have y okay, suppose I have y equal to all right, suppose y is equal to x to power of 3 minus 6x squared minus 9x plus 2. Okay, I want to find the maximum and minimum of the function, or local maximum, local minimum of this function. And also I want to know where it is increasing, where it is decreasing, on which interval it is increasing, on which interval it is decreasing. First thing I will do is that I will find dy by dx. Okay, this will be 3x squared minus 12x minus 9. Second thing I will do, I'm going to solve this equation. I'm going to solve this equation. I will put equal to 0. If I put equal to 0, I can factorize 3. I'm going to get x squared minus 4x minus 3. This is equal to 0. Now, to solve this equation, sorry, I will change this to positive so the answers are nice. So, now this you can factorize it to x minus 1 times x minus 3. If you factorize that, therefore you can easily get the values. So, if this is equal to 0, this is either x equal to 0, x equal to 1, or x equal to 3. Now, we have got these two values for x. Now, what I'm going to do is that I will draw a table of sign here. X. I have, these are our x-axis. Therefore, 1 is here, 3 is here. It should go in order. I cannot put 3 at the beginning and 1 next because this is x-axis. 0 also here. I don't care about 0, but now I know that x minus 1, here is 0, more than 1 it will be positive, and less than 1 it will be negative. Now, let us go for x minus 3. X minus 3, here is 0, and below that is negative, and then here is positive. So I can say y dash, which is multiplication of these, multiplication of 3 also doesn't matter because 3 is a constant number, doesn't change the sign. Here is positive, here is negative, here is positive. What do you understand about this? I understand my function is increasing here, it will remain flat here at one point only, and then decreases, and then it will be flat, and then increases. Therefore, I can say there is a maximum here and a minimum here. Therefore, at x equal to 1, I can find the value of y, which is, I have to substitute here. I can set 1 minus 6 is minus 5, therefore plus 4 plus 2 is 6. And when x is equal to 3, I can find the value of y is 27, and the 27 I am having here. Therefore, this is also negative, so this is y is equal to 2. Okay, therefore, you can see that at x equal to 1, you have got a maximum point, and at x equal to 3, you have got a minimum point. You may argue that because 6 is more than 2, therefore 6 is maximum, 2 is minimum. Actually, this argument is correct only if we know that this function is a continuous function. And also there is no other maximum or minimum. So in general, for this type of the functions, which we know the graph is like this, a continuous function, and the graph is similar to this graph here we are having, so you can argue like that. But in general, we cannot say because of the minimum, it should be less than maximum. Maybe the function is not a continuous function. Okay, now this is one of the applications. There is another application which comes to the second derivative of a function. Now look at this. I'm going to explain about this you can see that I have 4 different situations. Why I have 4 different situations? What I mean by that, you see, at the first one, y dash is positive because the function is increasing, is going up. From here, it goes up like that. Therefore, the function is increasing. Second one, also function is increasing. Therefore, y dash is positive. Third one, the function is decreasing. So y dash should be negative. And the last one also, the function is decreasing. Therefore, y dash is negative. Okay? We are always going from left to right because this is the way x is increasing. Therefore, we are saying x is increasing. Always x is independent variable increasing. We'll check what will happen to y. At the first two, as x increases, y also increases. In the second and third and the fourth, as x increases, y decreases. Now look at this. Here is concave down. You can see that it is downward. In that case, y double dash is negative. Here you can see that concave up. That means y double dash is positive. Now in the third one is concave down. Okay, you can see that it's concave down. So y double dash is negative. Here the last one is concave up. So you can see that y double dash is positive. Double dash means second derivative. Okay, so we understand the second derivative of this is positive. So using this, I can find a point is a maximum or a minimum point. Now, let's go back to our previous equation. We had dy by dx equal to 0 at x equal to 1 and x equal to 3. Now I want to know which one of them is maximum. This is a maximum point, or this is for the maximum point. Which one is for the maximum point? That means the y is maximum at this x equal to 1 or at this x equal to 3. Sorry. Okay, let us see what we can do. We are going to find the second derivative of this function. Let us see. The second derivative is denoted by d square y divided by dx square, which will be equal to, now I know that this is 3x squared minus 12x plus 9. Therefore, let me write here dy by dx is equal to 3x squared minus 12x plus 9 minus 12x plus 9. Therefore, this derivative of this will be 6x minus 12. Now, at x equal to 1, at x equal to 1, d square y divided by dx square is equal to 6 minus 12, which is negative 6, which is less than 0. So, your graph is something like this. So, from here you can understand at x equal to 1, we have maximum. Now, at x equal to 3, d square y divided by dx square is equal to 6 times 3 minus 12, which is clearly 6, which is more than 0. So this is concave up. The graph is like this. So this has got a minimum point. So it has a minimum point. Then at x equal to 3, we have minimum point. Okay, this is the second method to find maximum or minimum at any point. Okay, we can continue this kind of question in the next session. Thank you for watching.